The heat index hit 110 degrees in the Texas panhandle this week, and that is just the leading edge. The first major heat wave of the summer is building across the country, 10 to 15 degrees above average, peaking this Friday. The dangerous part is not the afternoon high. Forecasters are warning of record warm overnight lows, the number that decides whether a heat wave turns deadly. By the end of this report, you will understand why the nights are the real threat and what to watch for next. The first major heat wave of the summer is now building across the United States, and the language the national forecasters are using is unusually direct. Yesterday, the Weather Prediction Center stated that a large ridge of high pressure over the eastern part of the country will bring, in their words, the first significant heat of the summer, with temperatures 10 to 15 degrees above average. The peak is forecast for this Friday across the mid-Atlantic and the Northeast, and the records have already started to fall. 2 days ago, on Monday, the heat index reached 105 degrees across many locations in north and central Texas. The same day, out west, the Denver office noted that the all-time record high at its airport, 95 degrees, was within reach. And in the Texas Panhandle at Palo Duro Canyon, forecasters issued an extreme heat warning, the most serious heat alert in the system, for a heat index of up to 110 degrees. As of yesterday, 24 separate heat advisories were already in effect across the country, and that footprint is forecast to grow sharply as the week goes on. So this is not a forecast of heat that might arrive. It is a report on heat that is already here and still building toward its peak. But here is the part of this story that almost no one is paying attention to, and it is the part that actually matters most. The dangerous feature of this heat wave is not the number you will see on the afternoon forecast. It is a different number entirely, one that very few people ever look at, and the forecasters flagged it directly. They are warning of record warm overnight temperatures. To understand why that single detail is the most important thing about this event, we need to talk about what a heat wave actually does to the human body, and why it does most of its damage in the dark. The most dangerous hours of a heat wave are not in the afternoon. They are in the hours before dawn. And the reason comes down to recovery. The human body can tolerate a hot afternoon as long as it is given one thing afterward, a cool night. During the day, your body sheds heat by moving blood to the skin and by sweating, and that work places a sustained load on your cardiovascular system. At night, when the temperature normally falls, that load comes off, and the body recovers and resets before the next day. The night is the relief valve. What makes a heat wave lethal is when that relief valve never opens. When forecasters warn of record warm minimum temperatures, they are telling you that the overnight low, the coolest the air will get, will be higher than it has almost ever been. In some cities this week, the temperature may not fall below the upper 70s or even the low 80s at any point during the night. The body never gets its recovery period. It is asked to carry the cardiovascular load around the clock for days in a row, and for the elderly, for people with existing conditions, and for anyone without reliable cooling, that unbroken strain is precisely what turns a heat wave deadly. The people most exposed to this are the ones least able to escape it. The elderly, whose bodies regulate temperature less effectively and who often live alone. People with cardiovascular and respiratory conditions, who have the least margin to spare. People who cannot afford to run air conditioning through the night, or who do not have it at all. A heat wave with record warm nights does not strike at random. It concentrates its harm on the most vulnerable people in every city it reaches, and it does so quietly over several days as the strain accumulates. That is the profile of the event now building, and it is the reason the overnight numbers deserve far more attention than they receive. This is why heat is, year after year, the deadliest weather hazard in the United States, ahead of hurricanes, ahead of tornadoes, ahead of floods. And it is also why heat is so consistently underestimated. Its damage is invisible. There is no funnel cloud and no wall of water to photograph. The deaths are often recorded weeks later as cardiac or kidney failure, and the true toll only becomes clear when researchers count how many more people died during a heat wave than would have otherwise. The most lethal weather in the country is also the quietest, and the record that measures it is the one almost no one is watching. And there is a hard physical limit hiding behind those warm nights, a threshold the human body simply cannot cross. And recent science has revised it in a direction that should concern every American facing a humid summer. There's a point at which heat and humidity combine to exceed the limits of human survival, and the science on where that point sits has shifted. For years, the assumed ceiling was a wet bulb temperature of 35 degrees Celsius, a measure that combines heat and humidity into a single number. Above that, the theory held, a healthy person could no longer cool themselves by sweating, no matter what they did. But laboratory work has revised that figure downward, and significantly. Research from the PSU Heat Project, published in the Journal of Applied Physiology, found the real limit for young, healthy adults is closer to 31 degrees Celsius. Follow-up work extended the finding to older adults, where the threshold is lower still. To be clear about what that threshold means, it is not a temperature that people simply find uncomfortable. It is the point at which a healthy human body can no longer shed heat fast enough to hold its core temperature stable, even at rest, even in the shade, even with unlimited water. Crossing it for a sustained period is fatal. That extreme limit is still rare, and today it is reached mainly in places like the Persian Gulf and parts of South Asia. But the revised lower figure is the reason scientists now watch humid heat far more closely than dry heat, because the combination of high temperature and high moisture closes off the body's only cooling option. And it does so at numbers that are no longer comfortably out of reach during an American summer. That 4-degree revision matters more than it sounds, because it means the margin between an ordinary humid heat wave and a physiologically dangerous one is narrower than the public has been told. Humidity is the key. Sweating only cools you if the sweat can evaporate. And when the air is already thick with moisture, evaporation slows and the body's main cooling system begins to fail. The dew points forecast across the Northeast this week are climbing towards 70, which is exactly the kind of moisture-loaded air that keeps the body from shedding heat efficiently, both in the afternoon and through the night. And the cities make it worse. Concrete, asphalt, and brick absorb the sun's energy all day and release it slowly after dark, which is why a large city can run several degrees warmer than the countryside around it at night. Stack that on top of an already warm, humid air mass, and you get the record overnight lows that the forecasters are warning about. None of this is on the map most people will look at. The afternoon high is what gets reported. The overnight low, the dew point, and the survivability threshold are what actually determine how dangerous the week becomes. To understand how a single weather system produces all of this at once, we need to look at the structure overhead that is driving it. A heat dome is, in simple terms, a large area of high pressure that settles over a region and stops moving. Underneath it, the air sinks. Sinking air is compressed by the weight of the atmosphere above it, and compression heats it, so the air mass warms before the sun has done anything at all. That sinking air also dries out and suppresses cloud formation, which clears the sky and lets the full strength of the June sun reach the ground day after day. The heat compounds. Each cloudless day adds to the one before, because the overnight hours never fully clear the accumulated warmth. And that is why the peak of a heat wave comes at the end of the stretch, rather than the beginning. The scale of this is worth pausing on. This is not a local pocket of warm weather that a person could drive out from under in an hour. It is a single structure in the atmosphere large enough to cover much of a continent, and when it parks over a region, the heat it produces is measured not in one hot afternoon, but in the steady accumulation of day after day with no overnight relief. The longer the ridge holds, the more the danger compounds, which is why the duration of a heat dome matters as much as its peak temperature. The reason the dome stalls in place comes down to the jet stream, the river of high-altitude wind that steers weather across the country. When the jet stream is flowing quickly, weather systems move along with it, and heat is followed by relief within a day or two. But when the jet stream slows and buckles into large, looping bends, one of those bends can lock a ridge of high pressure in place for days. The atmosphere stops turning over, the lid stays on. There's a growing body of research into why these stalling patterns appear to be happening more often, and it points to the amplification of these atmospheric waves and to the rapid warming of the Arctic, which is heating roughly 4 times faster than the global average and weakening the temperature contrast that drives the jet stream. No single heat wave can be attributed to that mechanism alone, but the tendency towards stuck, long-lived ridges is consistent with what that research describes. This is the same atmospheric framework that has been driving the volatile pattern across the country in recent days, and that points to something most coverage of this heat wave is missing entirely. This dome is not staying in one place. It is about to cross the entire country. The same ridge of high pressure that breaks records in the east this Friday is forecast to migrate west over the weekend and threaten records on the opposite coast by Sunday and Monday. This is not 2 separate heat waves. It is one system, large enough and coherent enough to hold together as it slides across 3,000 miles of the country, setting records at both ends within roughly 72 hours. The western target is the part that should draw attention because it is the Pacific Northwest, a region built around being cool and mild. Yesterday, the Seattle Forecast Office was calling for highs in the mid-50s to low 60s. In the same forecast, looking ahead to the weekend, those forecasters raised the possibility of record highs on Sunday and Monday. The signature of the air mass tells the story. The temperature of the air a few thousand feet up is forecast to reach around plus 20 degrees Celsius over Washington state. the same loaded reading showing up in the east, simply transported across the continent. The Pacific Northwest is uniquely exposed when heat like this arrives, for two reasons. The region's natural cooling comes from an onshore breeze off the cold Pacific, and when the wind flips to come down off the mountains instead, the cooling shuts off and is replaced by downslope warming. And because the area is normally mild, a large share of homes were never built with air conditioning, so when dangerous heat does arrive, there is often no cool indoor space to retreat to overnight. A region that rarely sees this kind of heat is, for that exact reason, among the most vulnerable when it comes. This is a national event wearing the disguise of several local ones, and the heat is only the most visible part of what this single pattern is doing, because the same system is, at this moment, producing violent weather of an entirely different kind. A ridge of high pressure cannot exist on its own. For the atmosphere to bulge northward into a heat-building ridge in one place, it has to dip southward into a trough right beside it, and that trough is where the violent weather is being manufactured. While the ridge bakes the east, its partner trough is digging into the northern Rockies and the high plains, and the result has been 2 consecutive days of high-end severe weather. Yesterday, the Storm Prediction Center carried an enhanced risk of severe thunderstorms across the northern and central plains, warning of winds of 60 to 80 miles an hour, tornadoes, some of them potentially strong and large to very large hail. For today, a second enhanced risk covers the upper Midwest, with the forecasters warning of hail larger than 2 inches across, a few strong tornadoes, and wind gusts in excess of 75 miles an hour. The ingredients are substantial. Instability values running into the thousands, and wind shear strong enough to organize storms into the rotating supercells that produce the worst tornadoes. The point here is not that there is heat in one place and storms in another. The point is that they are the same machine. The sinking air that is baking the east and the rising unstable air spinning up tornadoes across the plains are 2 halves of the same buckle in the same jet stream. This is the atmospheric pattern that has been producing a string of high-impact weather across the country. And the heat is its core, not a separate story. And on the dry side of that same ridge, the pattern is producing a third hazard, one that pairs naturally with the heat. On the western flank of the heat dome, where the air sinks and dries as it comes down off the higher terrain, the conditions turn toward fire. That descending air arrives hot, fast, and stripped of moisture, and when it blows across ground that the dome has been baking for days, the fire risk climbs quickly. Yesterday, there were 23 red flag warnings in effect across the country, along with 8 fire weather watches, with the critical conditions focused on the Colorado Plains east of Interstate 25 and the western Nebraska Sandhills. This is the same heat, seen from a different angle. The dome that is driving record warmth and dangerous nights in one region is, on its dry flank, pulling the moisture out of the grass and brush and delivering the wind to spread any spark. And on the far side of the pattern, where the trough's energy meets thick Gulf moisture, the 4th hazard appears, which is flooding. Yesterday, forecasters were dealing with life-threatening flash flooding in southern Indiana, with 6 to 8 inches of rain reported in one town and water rescues underway, while the Missouri River ran in flood across several counties. So in a single 24-hour period, one weather pattern delivered record heat, strong tornadoes, critical fire conditions, and life-threatening floods. These are not 4 separate stories competing for attention. They are 4 faces of one continental system, and the heat is at the center of it. That explains what is happening in the sky. But to understand why this heat is arriving so early and so hard, we have to look beneath the surface of the ocean. The atmosphere takes much of its temperature from the ocean beneath it, and the Pacific Ocean has been quietly warming for 6 straight months. The measure that tracks whether the planet is tilting toward the warm pattern called El Niño currently sits at plus 0.48. By the official definition, that is still neutral. We are not yet in an El Niño, but the trajectory is what matters. 6 months ago, that same index sat well below 0 in cool territory, and it has climbed steadily season after season to where it is now, and it is still rising. That 6-season climb is one of the fastest swings from cool to warm conditions in years, and it has not happened in isolation. It follows a spring in which the heat kept arriving early. Records fell in April, again in May, and now the first significant dome of June has formed ahead of schedule, each step starting from a baseline a little higher than the one before. Taken together, that is not a series of coincidences. It is a season being loaded from beneath by an ocean that keeps storing heat, and the early arrival of this heat wave is the clearest sign yet of how much energy is already in the system. A warm ocean is an enormous reservoir of stored heat, and it feeds that heat and moisture into the atmosphere above it, raising the baseline temperature that every weather system then builds on. The warming has been loading the upper layers of the Pacific for months, and because the ocean changes temperature slowly, that stored heat will keep feeding the atmosphere through the summer and beyond. This is the same ocean engine that has been tracked through the developing Super El Nino, the slow build of heat beneath the surface that the surface gauge is only beginning to reflect. And here is the detail that should hold your attention. The country is already setting heat records, and the Pacific has not even finished warming into El Nino. Normally, the broad record-setting heat associated with a warm Pacific arrives later, after the ocean has fully heated. This heat is running ahead of that signal, arriving while the ocean engine is only partway engaged. That tells you the underlying forces are stronger than the calendar alone would suggest, and it raises a direct question about what the rest of the season holds once the Pacific reaches full strength. Before we get to that, there is one more thing worth addressing, because whenever heat turns extreme, a particular set of claims tends to circulate. Every time a major heat wave develops, the claim resurfaces that the heat is being engineered through cloud seeding, antenna arrays, or aircraft trails. The claim does not survive contact with the physics. A continental heat dome involves an amount of energy many orders of magnitude beyond anything such facilities could produce, and cloud seeding can, at most, encourage rain from clouds that already exist. It cannot build a ridge of high pressure or steer it across the country. The pattern driving this heat wave is the ordinary, well-understood behavior of a buckled jet stream, visible days in advance in every forecast model run by every major weather agency in the world. There is no hidden hand required to explain it, and there is no facility capable of producing it. The drivers are the sun, the ocean, and the physics of sinking air. With that set aside, the question that remains is what to watch for as this event unfolds. The immediate window to watch is the next several days. The heat peaks in the east this Friday, and that is when the record highs and the record warm overnight lows are most likely to be set. The single most useful number to track is not the afternoon high, but the overnight low. When the forecast low in your area stays in the upper 70s or warmer for several nights running, that is the dangerous configuration. And it is the signal to check on elderly neighbors, to find cool indoor space, and to take the nights as seriously as the days. The second thing to watch is the west. As the ridge migrates over the weekend, the Pacific Northwest is the region to monitor for record highs on Sunday and Monday, in a part of the country with the least heat infrastructure and the least acclimatized population. And the third thing to watch is the ocean. If the Pacific Index continues to climb through the summer, the ceiling on this heat rises with it, because this week is arriving with the ocean engine only partway engaged. The bottom line is straightforward. This is the first significant heat wave of the summer. It is already breaking records, and its most dangerous feature is the nights that will not cool, arriving on top of an ocean that is still warming, and inside a single pattern that is also producing tornadoes, fire, and floods. The heat is here, the peak is at the end of this week, and the season is only beginning. We will be tracking it as it develops.